46 is on slope fields in differential equations. So a differential equation, we've done a couple of these before. It's equations that have both f of x and f prime of x in it. So it has the original function and its derivative in it. So the ones that we've done before are the ones where we had to find what c was. So we had like f prime, we had to find f of x, and then find c. So these are going to be kind of similar, but these are all going to be what we call separable differential equations. So this is a huge, huge topic on the AP exam. So you typically have, well, always, you have 6 free response questions on the AP exam that are each worth 9 points. And one of these is almost always one full free response question. Okay, so we'll talk about the scoring, we'll talk about everything that has to do with that. So the first thing is, let's talk about like what a differential equation is and why it works. So it says, example, show that y equals x minus x to the negative 1 is a solution to the differential equation x times dy over dx plus y equals 2 over x. Okay, so notice how this equation has dy over dx, but it also has y. That's why it's a differential equation. Okay, this dy over dx is y prime. So we want to find y prime. So y prime is going to be 1 and then plus x to the negative 2, right? Because so we have the minus and then negative 1 x to the negative 2. So we're just going to show that if we plug it in, we do get this 2x on the other side. So we're seeing if this is true or not. So we have x, and then dy over dx was our y prime, so times 1 plus x to the negative 2, plus y. Well, what was y? What can I replace y with? X minus x to the negative 1, right? That's what y was. And we're seeing that that's equal to 2x. So when I distribute my x in, I get x times 1 is x, and then x times x to the negative 2 is 1 over x, right? X to the negative 1. And then plus x minus 1 over x. And is that equal to 2x? Yep. 2x is equal to 2x, so it works. Okay? So that was just verifying that a differential equation was true. So it's saying, if I had this solution, y equals x minus x to the negative 1, does it work in that differential equation? But that's not necessarily the only differential equation. Like I could have had different constants and so on that would have worked. So the hard part is going to be actually finding what y is if you are given a differential equation. So it's kind of like going backwards. You have the differential equation and you have to go backwards to learn what y is. Some of these are not easy. Okay, so I don't know, people are singing next door? That's kind of weird. So sometimes things are separable, which are the ones that we do in AP Calc AB, and sometimes they're not separable. So if you go on to take advanced math next year, you would see things that are not separable. There's an entire branch of mathematics dedicated to this. So when I was in grad school, some people got their PhD in ODEs, ordinary differential equations, or PDEs, partial differential equations, right? So there are entire branches of mathematics dedicated to this. It's very important in physics and engineering and so on. All right, so number 1 says sketch a direction field. So in order to find what our y equals equations are, sometimes it helps to look at the slope fields, or sometimes you hear it called direction fields. These are very strange. These are on the AP test. So you'll often have a picture that looks kind of like this, and it says, at the 12 points listed, sketch the slope. Right? I don't know how many points are listed here, but we'll see. So here's our little table. And it says sketch a direction field to find the solution to y prime equals x plus y and y of 0 equals negative 1. So let's do a little bit at a time. So it's saying for this problem, y prime is equal to x plus y. So we were taking the x value and the y value of a point and adding them together. So if I'm at the point negative 2 comma 0, when I add my x value and my y value together, what do I get? Negative 2. That's going to be my slope at that point. So go down to your little picture here. And at negative 2, comma 0, this point right here, we're going to have a slope of negative 2. It's a little bit difficult for those of you that are art challenged, right? A negative 2 slope means that you would go, don't draw this, but you would go down to right 1, right? We're going to point in that direction towards that point right there, okay? But all we're going to do are these little, like, marks. So if you look at the back page, see all these things here? We have all these, like, direction fields. That's what we're doing. We're doing just the little marks. Like a magnetic field, kind of, right? Yeah, exactly. So if I do -1, 0, at -1, 0, my slope is going to be -1. So it's going to point towards this right here. It's going to go like right there. All right, at 0, 0, my slope is 0. At 1, 0, my slope is 1. And at 2, 0, my slope is 2, so a little bit steeper. All right, now we're on the next row. So now I'm at a height of 1. -2, 1, what's my slope going to be? -1. So it needs to look like this slope that was right there, because that was also -1. And you can kind of say, okay, I'm going to go down 1, right 1, I'm pointing in that direction. All right, the next one is going to be 0. 0, 1 is going to have a slope of 1. 1, 1 is going to have a slope of 2. And 1, 2 is going to have a slope of 3.
Does it matter if it's negative or positive?
It does matter if it's negative or positive, yes. So a negative slope goes downwards and a positive slope goes upwards, right? All right, so -2 and -1. So I'm going to have -3. So that's on the bottom row here. So I'm going to have a slope of -3. Then I'm going to have a slope of -2. And then I'm going to have a slope of -1. And then I'm going to have a slope of 0. And then I'm going to have a slope of 1. Oh, I don't know why I wrote 0 there. Hang on, -2. It is. All right, so let's say I needed this top row. So you don't always have to draw out this like T-table thing that I'm doing. Like, especially on the AP test, like don't waste your time doing this. A lot of times it's a very easy thing like this where you're just doing x plus y. So if I'm up here at this top point, that is at 1, 2, so -2, 2. What should its slope be? 0, right? Do you guys see the pattern? All of these are 0. It would continue that all the way down. All right, how about the next one? So -1, 2. 1. 0, 2. 2. And then 3. And then 4. It gets super steep. All right. Now the second part of this said sketch the direction field. So we did that. We sketched the direction field. And then find the solution to y of 0 is equal to 1. I should say find the solution curve. Write in curve there. So we're going to sketch in a curve. So that goes through the point 0, 1. So there are a whole bunch of curves here. You just can't see all of the different curves. Okay, so let me show you some curves that we have. Don't draw this in, but just look. So I have here, and then I have there. That's where it's turning. I have here, and then I turn there. I have here, and then I turn there. Do you guys see it? At some place, you have a slope of 0. That's what it's saying. So I have lots of curves in there. We want the curve that goes through 0, 1, this point right here. So it's going to have a slope of 1 there. It's going to go along that curve, and it's going to turn. So it's going to look something like that. There's a slope of 0 that would be somewhere in here. You don't see it, but it's there. There's an infinite number of points to this curve. Oops, man, I keep messing up that second part of it. It's going to go right along that line. So that's a solution curve. Luckily, you don't often have to draw on the solution curve. I think I've only seen that on like one free response question. Usually just draw the slope fields. Okay? Does this make sense? All right, so let's do the next one, and we'll kind of chunk it off. So let's do the ones with a height of 0 first. So now I'm using the equation y prime is equal to y minus 2x. So I have 0 minus 2 times -2. So what is 0 minus 2 times -2? Close. Positive 4, right? So at -2, 0, I'm going to have a slope of positive 4. Really steep. And then I have 0 minus 2 times -1. 2. Oops, that looks a little more like 1. It's not like, they're not super picky about your slopes, but. All right, and then 0 minus 0 is 0. And then 0 minus 2 times negative 1, or 2 times 1, I mean, is negative 2. So now make it the same slope, but just negative as this other one. So these two are the same. And then 0 minus 2 times 2 is negative 4. It's going to look like that. You guys get it? Now we do the next row. So now we have all these heights of 1. So I have 1 minus 2 times negative 2. So I get 5, so it's super steep. 1 minus 2 times negative 1 is 3. 1 minus 2 times 1 is negative 1. And then 1 minus 2 times, oh wait, did I mess up my spot here? Hang on. 1 minus 2 times, maybe I messed one up. What did I have? 1 minus 2 times 0 was 1, and this was negative 1, and then I think this one's negative 3. So I have 1, negative 1, negative 3. Did you guys get it? Do I need to finish that one, or you get the gist? You understand slope fields? They're not very fun, but they're easy points in the AP test. So usually that's worth like 2 points, maybe 3 points if they're feeling crazy.
How specific are they about your slopes?
Usually the way that they grade them is they'll say something like all of the positive slopes are in the positive direction. So they don't like really test to see if it's like 3 versus 5 necessarily.
Okay.
But they look so that all of them are positive. So you would look at these 4 to make sure that they're going up. Then they would look at actually 5 to make sure they're going up. And then they would look at these ones to make sure they're going down. And then they would look at any of the 0 slopes that you have. So they would look at this one as well. So that's really as specific as they get. Occasionally they do, this is rare, but maybe they say comparing the slopes. So maybe you have one that's a slope of 1, they might compare it to one that's a slope of 4. But it's never like 1 versus 2 or anything like that. Those are too close. Okay? All right. So it says, note, you can check your solutions with Grapher. So I can show you guys this next time. We don't have a ton of time today. But I kind of ran you through the steps on how you can do that. So one of the steps will put the whole slope field, which is really cool to see the slope field. And then when you actually do the this one here, it will give you this curve. And see how that curve kind of goes along all those slope fields? So there's a lot of different curves in there, but that's the one that goes through the point 1, 0 right there. You guys see? Can you guys visualize where these solution curves are now? Do you see them all? These depend on what your C value is. So they're the same shape, but it depends on what C is. Yeah?
Are they supposed to go, so they're not necessarily right on top of the arrows, they're just like following the same curve?
The arrow is basically like the equation of the tangent line at those points. So remember how we drew the tangent lines in? That's what those arrows are. Okay. The slope, right? Slope field. Yeah.
It's sort of like a current.
Yeah, it's like a current,
line would
totally.
Follow.
Like little fishies.
And no matter how far, like how big it is, it still has the same shape. Its current keeps the same.
Exactly. Yep, I like thinking of it as the current. That's a great idea. All right, so the differential equations that you're going to need to know how to solve for AP Calc are called separable differential equations. So you're going to be able to separate your x's, separate your y's. Usually these are worth either 5 or 6 points of that 9-point free response question, okay? Usually 6 points. And they get harder. It seems like they get harder every year. There's always like more things they want. So now they're really big about domain, and we'll talk a lot about domain. So it says find the particular solution to the differential equation with the given initial condition. Do you guys remember what I mean by initial condition? It's the value that finds your C value for you. So that's going to find our C, like plus C. All right, so here's what we're going to do. Do you remember in U substitutions when I had you write like U equals something and then we did du? I didn't have you write du over dx. I instead had you put the dx over on the right-hand side. I separated those two things, the du and the dx. We're doing that here. We're going to separate, instead of y prime, we're going to think of this as dy over dx, and we're going to separate the dy and the dx. And we want them to be on the numerator. So I want to take that dx, and I'm going to multiply it to the right side of the equation. So it's going to be on the top level. Does that make sense? So when I do that, I'm going to have a dx over here, and I'm going to have a dy over here. And I want to separate my variables. I want only x's on the right side, only y's on the left side. Okay, so if I'm separating variables, I'm going to keep the sine of x where it is, and I'm going to do 1 over y squared over here on the left. If you do not do this step, you will get 0 points out of the 5 or 6 points. Okay, isn't that dumb? I think it's dumb. But you will get 0 points. So do that on your AP test. All right, so now we want to integrate it. So you can do your integration sign in front of each of those, or you can say, oh, well, I know this is y to the negative 2 dy, so I'm going to rewrite it. So we have that. Okay, now we're going to integrate each side. So if I have y to the negative 2 and I add 1 to the exponent, I get y to the negative 1. Yes, thank you. You guys don't get a point for that. You know how many times you guys leave off x. All right, so I'm going to get negative 1, y to the negative 1 equals cosine of x. Is it negative or is it positive cosine? Negative cosine of x. And then I put the plus c on one of the two sides. You don't have to put it on both sides. It's kind of redundant. So I usually put it on the x side. Okay, once you have written plus c, what I've found in the 10 or so years that I've taught calculus is my students have it's easiest for them if they just find c right now, instead of finding what y is equal to with c in it and then finding it at the end. So we're going to go ahead and find what c is. So we're going to use the y of pi equals 1/2. So I'm going to plug in pi for x and 1/2 for y. So I get negative, and then cosine of pi is -1. And then if I have 1/2 to the -1, that's 2, and then I have that negative out front. So I have -2 is equal to 1 plus c, so c is equal to -3. Now put back in. So now we're going to put it back in to here, so wherever we last had that c. So we're going to have negative y to the -1 equals negative cosine of x, and our c value is -3. And then we're almost done, but now we solve for y. So when I see negative y to the -1, what that means is -1 over y equals negative cosine of x -3. There are a lot of negatives going on. So let's get rid of the negatives. Multiply through by -1. So we get 1 over y is equal to cosine of x plus 3. Last step, I need y by itself. Anybody know the trick to get y by itself? You can like cross multiply, or you can flip both sides. Do you guys see how it's 1 over y? So if I want y by itself, I do the reciprocal of both sides. So I get y over 1, or y, is equal to 1 over cosine of x plus 3. That is our solution.
But they want us to write it y equals secant of x plus 1/3.
Nope, you can't do that because you can't break apart the cosine of x plus 3. If it was just 1 over cosine of x, yes, I would write it as secant, but since you have that plus 3, you can't change it. All right, we're going to skip b because I made a little typo, so we're going to skip it. So let's go to c. So again, we're going to separate our variables. So this can be a little bit tricky to do sometimes. Okay, we know that we want the dy and the dx to be on the top level. We can't have over dx, right? It goes with our integration signs, so they have to be on that level. So what do I have on the left side? How do I get that y over there? You can cross multiply. Yeah, you could do that. So if you cross multiplied, you'd have dy times the square root of x equals y dx, but now we haven't separated our variables, right? So how do I get the y that was on top? How do I move it to the other side? I divide it over. It's like multiplying by 1 over y. I multiply by 1 over y to get it over. So I have 1 over y dy equals 1 over the square root of x dx. So I've now separated my variables. That's the most important step. If you don't do that, you get 0 points.
Why isn't it just square root of x since the square root of x is on the denominator?
Because it's staying on this right-hand side. The dx is going over here, but it's on the denominator already.
Okay.
So now this is x the negative 1/2 that I'm integrating. And 1 over y, you can leave it like that because do you guys remember what the integral of 1 over y is? Natural log of the absolute value of y, yep. And then this is going to be x the 1/2 with a 2 out front, and then plus c. So now we're going to plug in our point, which is 9, 1, right? 9 was x, 1 was y. So I'm going to have the natural log of the absolute value of 1 equals 2 times 9 to the 1/2 plus c. So I get 2 times 3 plus c equals natural log of 1? 0. So c is equal to negative 6. So I subtract that 6 over. So I get natural log of the absolute value of y equals 2x the 1/2 minus 6. Okay, and I can actually solve for y. Some of them are tricky, like sometimes it's not really like a function. You can't get the y by itself. But if you can, solve for y. So how do I get rid of natural log? Yeah, it's e. It's like e raised to both sides. So it's kind of weird looking. So it's going to look like this. Absolute value of y equals e to the 2x raised to the 1/2 minus 6. Or 2 square root of x minus 6. You could do that as well. And then, how do we get rid of the absolute value? Grant, what do you think? Plus or minus, good job. You do not just erase the lines. Now here's the weird thing. So they used to accept this as an answer on the AP test, but they will not accept it now. This is the point 9, 1. 9, 1 must work. So make a choice with your plus or minus. So we have to decide which one it's going to be. So let's plug in 9. If I plug in 9, I have 9 to the 1/2 is 3. 2 times 3 is 6. 6 minus 6 is 0. E to the 0 is 1. So I get y equals plus or minus 1. What do we want y to equal? Plus. So it's plus. What does the AP test do most of the time now? Makes it the negative 1 because people do what you just said and they get rid of their absolute value by erasing the lines, which is not the correct way. You can't just erase the lines. You have to put plus or minus. Now you have to make a decision. Okay, so our final answer is going to be y equals e to the 2x the 1/2 minus 6, like that. Or you could do 2 square root of x minus 6. Okay, kind of complicated, right? All right, so let's start the next one. So this one, again, we have to separate our variables. Now the dy over dx is on the right-hand side. And the variables are pretty much separated for you, but you got to multiply that dx over. So it's going to be cosine of x dx equals 2y plus e to the 3y dy. So we've separated, and now we integrate. You can do the integration sign on your separation step. It doesn't matter. So if I integrate cosine, what do I get? Sine of x. I'm going to put the plus c with the x, right? Sine of x plus c. This side's going to be y squared plus, how about e to the 3y? 1/3 e to the 3y, good. And we don't need the plus c on that side. This is one where you're not going to be able to solve for y. Can you guys tell that already? If you got an e to the y, there's a lot of things. You could do a natural log, but it's like, wait a second, what about that other one?
There's like someone solved for y, like just not us.
That's where you would use like the separable differential equation, like, or not the separable, the slope fields and stuff to find an approximation for the curve. And there are ways to.
We don't have a
There are ways to write an approximation for the polynomial. I don't know. Okay, we won't go there. All right, so we're going to plug in 0. So I have sine of 0 plus c equals 0 squared plus 1/3 e to the 0. So be careful, e to the 0 is not 0. A lot of people will try to get rid of that. So we have 1/3 times 1, so 1/3. Sine of 0 is 0, so c is equal to 1/3. So when we go back in, we have sine of x plus 1/3 equals y squared plus 1/3 e to the 3y. And if your AP test had this like as a multiple choice question, maybe this is the solution. They just leave the y's in there. Or they could do fancy things, like you could clear denominators by multiplying through by 3. So you might see things like 3 sine of x plus 1 equals 3y squared plus e to the 3y. I mean, you could see weird things like that as well. Okay, so just look for things like that. Okay, so let's stop there.